So now in this chapter, we're going to talk about conic sections. And one of the conic sections is called an ellipse. And an ellipse is an oval shape. And it's got a center in the middle. And it's got two focus points. We'll call it focus 1 and focus 2. Now the points on the ellipse are formed because if I take any point on that ellipse, I'll take this point here, just a random point, and I take the distance from this point on the ellipse to the first focus point, and then to the second focus point. We'll call this distance here distance 1 and distance 2. If I add up distance 1 and distance 2, that will give us a total distance. We'll call it D. Then if I take another point on the ellipse, let's say I take this point right here. If I take that point, the new point, to the first focus point and then to the second focus point, and I add up those distances, it's going to give us the same distance D. Same thing goes if I take another point. Let's say I take this point over here. If I take the distance from focus 2 and the distance from focus 1, and I add those up, I'm going to get the same distance. So all of these points are formed because as I trace the points around the ellipse, those distances to each focus point will add up to the same total distance. And that is how the points on the ellipse are formed. Now on the ellipse can be facing two different ways. We have what's called a major axis. And the major axis is the axis from one end to the other that is the longer of the two axes. So in red, that would be the major axis because that's the longer of the two. The minor axis is going to be the shorter of the two when it goes from one end to the other. Now, at the end of the major axes, we have what's called the major vertices. Those are the points, the ordered pairs, on each end of the major axes. And then we have the minor vertices, that are on each end of the minor axis. And then, of course, we have the center in the middle, where the major and the minor axes cross. And then we have the focal points, I'll call it F1 and F2. And the focal point always runs on the major axes. The focal points will never be on the minor axes. Now, the formula for an ellipse will look like this. If the major axis is running horizontal, so this is if the major axis is horizontal. And this is also if the center is at the origin. So the center would be at 0, 0. So our formula would be x squared over a squared plus y squared over b squared is equal to 1. Your a is always going to be bigger than your b for an ellipse. And so if your a is underneath the term with the x in it, like this case, that's how you tell if your major axis is running horizontally. And if the a is under the y, the bigger number is under the y, then you know it runs vertically. Now, in order to find your focus points, you need another formula. C squared is equal to a squared minus b squared. And this is used to find the focus points. Now, the A and the B helps us determine the length of the major and minor axes, which also helps us find the vertices. So when you look at your ellipse, if it's running horizontally, that means your bigger number is under the x term. So whatever your value of A is, that is the distance from the center, from your center to your major vertices. Your value of B is going to be from the center to your minor vertice. And the C is what we use to find the focus point. The C is from the center to the focus point. So whatever that distance is that you find for C, that's how you figure out what your focus point is. You come out C distance in either direction from your center. Because this is only 1/2 of the ellipse, from here to here, let me highlight it in a different color. Let's do yellow. That way you can see it better. Because this distance from here to here is only 1/2 of the major axes, I know that the length of my major axes is going to be 2A. And the same goes for my minor axes. The length of my minor axes will be 2B. If the center is not at the origin and you have a shift, so instead of the center being at 0, 0, maybe the center is at 2, -3. If it's been shifted horizontally and vertically, then your formula is going to look like this. So you're going to have x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. So notice I subtract or add something to my x and I subtract or add something to my y to get my shift. So my center will be hk now instead of 0, 0. Other than that, everything else holds true. You still use this formula here to find your value of C. You still have your A is bigger than B. Your graph is still going to look like the picture that I just drew. It's just that the center is not going to be at 0, 0 anymore. If your major axis is running vertically, meaning the longer axis is up and down, it's the same thing. Here's your center. Here's your focus. Here's your second focus. The distance from the center out is still going to be A. It's just going to be running vertically now. And your minor axis is going to go across this way now. So this distance from the center out will be a distance of B. And then, of course, from the center out to the focus point will be a distance of C. Then your major vertices will run vertically, and your minor vertices will run horizontally. So your major axes, the length will still be 2A. It's just running up and down now instead of side to side. The same thing, your minor axis will be 2B. You're still going to use the formula C squared is equal to A squared minus B squared to find your focus point. Your A is still going to be bigger than B. However, here's the difference. When you look at your formula, the smaller number will now be under the x term, and your bigger number, which is your A, is now going to be under the y. That's how you can tell if the major axis is running vertically or horizontally. You look to see what number is bigger in the denominator and look to see what term that's under. If the bigger number is under the y term, then it's running vertically. If the bigger number is under the x term, then it's running horizontally. So this is the case if your center is at 0, 0, just like above when it ran horizontally. If your center has been shifted, then you just use this formula, x minus h squared over b squared plus y minus k squared over a squared is equal to 1, and your center will be hk. Everything else still holds true. It's just that it would be running vertically now. Last thing I wanted to go over with you is something called eccentricity. Eccentric means off center. And eccentricity helps us determine how stretched out, how elongated this ellipse is. And there's a formula for eccentricity. The formula is you take your value of C, that's the same C that you use to find your focal point, and then you take that over A. If the eccentricity, I'll just call it E, if your E is 0, then you're going to have the special case where your ellipse is a circle. Just like a rectangle has 4 sides, and then you get the special case when all 4 sides are the same, you get a square. In oval or an ellipse, if your major and your minor axes are the same, then you get the special case that it's a circle. So if this is my circle, it's just a special case where my major and my minor axes are the same, so it's perfectly round. As E gets closer to 1, then your ellipse is going to get more and more stretched out. The closer to 1 you are, the more squished it is and the more elongated it is. When your E is equal to 1, then it's going to be completely squashed and it's just going to be a line. So this would close in and it would get squished. The closer it is to 0, the closer it is to a circle and the more round it is. As E gets closer to the value of 1, your ellipse is more stretched out and elongated, and the closer you are to 0, it's more and more like a circle.